All right, 713, does the limit exist? So let's define a limit here. So further adventures of Benny and Bertha, right? We're going to approach one-sided limits, and we're going to formalize this. So let's start with 29 here. Benny and Bertha plan to meet their friend Sally Snail. Sally is currently located as shown on the diagram. Benny starts at the point on the left. Sally starts on the right. Where do they think they will end up? Well, they'll end up at Sally Snail. That's where they're meeting. So Bertha starts at a point on the curve to the right of Sally Snail and moves along the curve left, right? Where does she think she will end up? At Sally Snail. So if we look at C here, unbeknownst to Benny and Bertha, Sally plans to get her shell shined, and since she moves slowly, she is already headed to her appointment. So she has moved. She's no longer there. So notice that there's a hole there, right? How does this impact where they think they will end up? They still think they will end up at the hole or where Sally Snail was. It doesn't impact it. It doesn't matter if she's there or not. They are approaching that same point. So does the limit exist in part C? Yes. Why? Because it's predictable. That is, Benny and Bertha predict they will arrive at the same location. So if you can predict that they arrive at the same location from left and right, that's the idea of a limit. What are we approaching from the left and the right? Okay, so looking at 30. Use the graph at the right to complete the part. So we got Benny starts at a point 1, 3 and moves left, right? What y value does he think he will end up at 3? He will end up at 2. Bertha starts on the right. She's approaching 3. She also thinks she will be at 2. So write the limit statement. So this would be the limit as x approaches 3 from the right and the left, right? So of f of x is 2. So we would do that from 1 from the right and 1 from the left. So remember yesterday we talked about this plus and minus, plus being coming from the right, minus being coming from the left. Right? Suppose you gently pick the bugs up. Where should you place each bug if you want to evaluate the limit of f at 1? Well, Benny's going to go to the left of 1. Bertha's going to go to the right of 1. So if we look here, now if we look at the limit as x approaches 1 from the left, that would be Benny. He's approaching 2 from the left. Okay? But if we look at Bertha coming from the right, if she's approaching 1 from the right, she's actually approaching 3. So that would be, up there. Okay? So the limit, therefore, the general limit does not exist because it's not approaching the same number. So it's not predictable. Okay? Cool. So going through these, we're going to do some of these limits here. So the limit as x approaches -2 from the right. So as we approach -2 from the right, we're at 1. I wish I could write in there, but I'm just going to kind of go through these. So the first one is 1. Okay, as we approach -2 from the left, also 1. So the general limit is 1 since they're approaching the same. Okay, now let's look at 0 from the right. That's 1 also. 0 from the left, 1. General limit, 1. All right, now let's look at 2. 2 from the left is 3. 2 from the right is 6. So because they're not the same, the general limit does not exist. Okay, looking at the next problem is from a table. So if we look at this table, we have a function. So we have 2.9 approaching to 3, and then from the other side, 3.1 approaching to 3. So if we look here, we'll write two limit statements, right? So the limit as x approaches 3 from the left, and the limit as x approaches 3 from the right of h of x. And we can see both of these are approaching 6.2. So therefore, our general limit does exist. They're approaching the same thing. So what is the value of h of 3? It's not there. We don't know. It doesn't give it to us. We can predict it, but we don't know that if it's there or not. So it's the idea of Sally Snail. Okay, and then so 33, what if you're given an equation? Okay, so if we're given an equation, we just plug in if it will allow us to plug in. So if you look at A, and you have the limit as x approaches 1 of x squared plus 2x over x plus 1, just plug in 1 squared plus 2 times 1, 1 plus 1. So you end up here with 1 plus 2 over 2, or 3/2. That's your limit. Now, if you get something like B, and you plug in, what happens? You get 0 over 0. This is called indeterminate form, meaning we can't determine the limit yet. So what we need to do is, can we get rid of this factor on the bottom so then we can plug in? So if you factor this, the top, difference of squares, the x minus 1 will now cancel, and I now just have x plus 1, and I can plug in 1. Sorry. So my limit is 2. Okay, the same thing with C. First thing, try to plug in. Again, indeterminate. So can I factor or something, right? So in this case, we're going to multiply by a conjugate. So we're going to go x minus 1 over square root of x minus 1 times square root of x plus 1 over square root of x plus 1. So just leave the top. The denominator is going to become x minus 1, and then that's going to cancel. So we have square root of x plus 1. Plug in 1, and we get 2. Okay, looking at D, the limit as x approaches 1, x minus 1 over x plus 1 squared minus 4. So again, plug in 1 minus 1 is going to be 2 squared minus 4. Again, going to get 0 over 0. So got to do something. So can we factor? Difference of squares, so x plus 1 plus 2, x plus 1 minus 2. X minus 1 cancels. I have 1 over x plus 3. So my limit is 1 over 4 when I plug in 1. Keep going, looking at E. If I plug in 1, I get 0 over 0. So we're going to make a common denominator. Then we'll multiply by the reciprocal. Take out a negative 1 down here to make this. So it'll cancel. I have x over negative 1. Plug in a 1, I get negative 1. The last one here, there's nothing I can do to this. So I get 1 over 0, which is undefined. So this limit does not exist. Can't factor that, can't change it. Okay, I'm going to leave 34 as a challenge for you. So take this and see if you can determine those based on what we now know about limits.